Hi, in this module we have learned a lot about arrays. In this particular lesson we are going to wrap up whatever we have learned so far on arrays. Okay, as we have seen in Java, arrays are objects. They are not the primitive or built-in data types. And once the array is created, its size is fixed. And if we want to change the array size, then we have to create a new array. There is no way we can change the size of the existing array. And as we have seen, all the elements in the array are of same type. So if it is an array of integers, all the elements are integers. It is not the case that some of the elements can be integers, some of the elements can be float values. That is not the case. And because the elements, they are all unnamed variables, they don't have any name. So all the elements in the array, they can be accessed only using their index value or the positional value. In Java, the index of the array starts with 0. Arrays have a 0 based indices. So if the size of the array is n, then the indexes will range from 0 to n minus 1. Otherwise, if the size of the array is 5, then the first index will be 0 and the last index value will be 4. Now let's move on to creating arrays. As you can see here, because the arrays are objects, we have to use the new keyword to create a object or to create the array. So here we are defining an array of integers and the size is 10. If we don't want to use the new keyword, or if we know the element values at the creation time itself, then we can use the array initializer. In this case, we don't need to specify the array, but in this case we don't need to specify the size of the array, but the size of the array will be automatically equal to the elements that are present in the array initializer. Also, we have anonymous arrays. Here new int 1 2 3 4 5, it is an anonymous array. We are creating that anonymous array and we are assigning to a existing variable of integer, variable of array of integer. So here we are able to see all the ways of creating arrays, like using new keyword, using array initializer, even using the anonymous array. Okay, when we are creating the array, we are defining a variable that can refer to array of integers. The type of AI is array of integers. So that's what we are able to see on the left side, int square brackets. So here, while defining the variable or variable type, you cannot specify the size. If you give the size there, it is going to give a compilation error, because size is not part of array type, but the size is only the part of the object or the array that is created. So when you are creating array using the new keyword, you should specify the size there. Otherwise, again, it's a compilation error. Please remember, whenever you are seeing the code, on the right side, when you are creating the object, you have to give the size of the array, but on the left side, when you are creating the array type, you should not mention the size of the array. Also, because as I said, the arrays are objects, so the elements inside array will be initialized with a default value. For example, if you have just created a array of integers, all the values or all the elements in that array will have a value of 0. If it is of float or double, then the values will be 0.0 or double or float. If the array is of type boolean, then all the elements will have a value of false. If it is of any other type, reference type, like if it is an array of strings or if it is an array of date, then all the elements will have a value of null. They won't be pointing to any string object or date object. They will be pointing to null. Now let's look at the ways in which we can iterate through array elements. For example, here we have a array of integers. So if you want to iterate that array, or if you want to print, or if you want to do something with all the elements in that array, then we have two options, like either use a loop, for loop, using the index position, or use a for each loop, also called enhanced for loop. Okay, we can see the difference in the next lesson, or the benefits of for each loop or limitations of the for each loop in the next slide. But in this slide, we can see when we are using simple for loop, we are defining a index of type integer and the index starts with 0. And in each iteration, we are accessing the element at index, particular index, using the expression ai square brackets inside index, and then the index, the maximum value of index will be 1 less than the length of the array. So that we can clearly see in the first for loop. In the second for loop, there is no concept of index, as we can clearly see. For each element in the array of integers, we are bringing that integer and we are simply printing that integer. Again, in for each loop, there is no concept of index at all. Okay, let's move on to next slide. In this slide, we are looking at the benefits of for each loop. That is, as we have seen in the previous slide, for each loop or enhanced for loop is very concise, very precise, and also it is very less error prone when you are doing the coding, because there is no concept of index when we are using the for each loop. So there is no chance of going out of the bounds of the index. So array index out of bounds exception won't occur. But whenever you are using that index, the simple for loop using index, you should be very careful. Otherwise, you may be accessing the element at index number greater than the size of the array, or you may be giving a index value less than 0. In all those cases, whenever the index is not valued, that is not between 0 and n-1, then you are going to get an exception, and that will terminate the program if we don't catch that exception, and we will see that in a different lesson. But when you are using indexes, it is very risky. Not very risky, but you should be careful. In case of for each loop, this is less error prone. But we have a limitation, as we said already. In case of for each loop, we don't have index, so you can't access a element at so and so index, or if you need the index values when you are iterating through the loop, you can't have that. So it is not possible to iterate only some elements, like element at index number 1, 5, 7. This is not possible. We have to iterate continuously. At some point we can break, but we can't use index values there. Also, because we are discussing arrays, as we know, the main method is the entry point into Java program. So Java program will be called from Java virtual machine, and when the JVM launches this Java program, it is going to create an array of strings, and it is going to pass that array to the main program. So every main method, it gets a array of strings, and we can use those values as input to our program. Here I have created a simple hello world program, and I am printing whatever string elements that are passed to the main method. Here I am compiling the program and passing 3 parameters, that is Naga, Chandra, Manohar, and we can clearly see the string is printed. When each element is printed, we can see all those 3 values printed properly. Because arrays, or the elements of the array themselves can be arrays, we can have multi-dimensional arrays. Okay, so the Java supports multi-dimensional arrays in this way, because the elements of array themselves can be arrays. So here we have 2-dimensional array, 3-dimensional array, even multi-dimensional array. There is no limit on this depth of the array as far as Java language is concerned, but Java virtual machine can pose some limitations here. Here we can see, whenever we are creating a multi-dimensional array, the number of square brackets on left side is equal to the number of square brackets on the right side. Also on the right side, we can give the size for each dimension, like first dimension, second dimension, third dimension, or fourth dimension, or whatever number of dimensions are there. We can give the dimension values for all those dimensions, or we can skip the value of skip the size of those dimensions from the second dimension onwards. But you should give the size of the first dimension. So here you can see, in every case I mentioned the size of the first dimension as 10, but in all cases either I have omitted the size of the dimensions from the second dimension itself. Okay, but if you see the last example here, I am not giving size for even the first dimension. So it's clearly an invalid syntax or invalid expression, and you are going to get a compilation error. So please remember, the number of square brackets on the left side will be equal to the number of square brackets on the right side, and while giving the size of the array, you have to give the size for at least the first dimension. You can skip or you don't need to provide the size for remaining dimensions. Here we are seeing the ragged arrays. In Java, I mean, the size of each dimension need not be equal. Here we are seeing a two-dimensional array. So at the first dimension we have two elements. So and first element is having an array of 5 elements, and the second element in the outer array is having a array of 2 elements. So when the size is not equal, we call that a ragged array. So in the second example, we are seeing the ragged array using the array initializer. Then we have looked at array utility class. This is a class that has a couple of utility or helper methods. So the first two methods, like toString and deep toString, they are used to print the array. Okay, if we simply print an array using system.out.println, you don't see the contents or the element values inside that array. But using arrays.toString or arrays.deep toString, we can see the contents when we are printing. So if it is a one-dimensional array, you can simply use toString. But if it is a multi-dimensional array, then you have to use deep toString. Here I have also presented how the values will be printed. Also, we have a method called filled. As I already mentioned, the elements will have a default value. If we don't want the default value for some elements, if we want to fill that with a given value, we can use the method fill. Also, we can copy the elements for a particular range or all the elements using copy of or copy of range methods that we have already seen in the program. Also, we have two more methods that we have seen. That one is sort, which is used to sort the contents of the array, and another one is binary search to search the elements inside the array. So these are the methods that we have seen. There are couple of other methods, but at this stage, because we haven't seen how to create classes and many other things related to class design and class concepts, object concepts, we are not going to, we did not look at those methods. We will cover them when we come across. Okay, and last but not least, at the end we have written a couple of programs, and we especially written we have implemented 4 sorting algorithms: bubble sort, insertion sort, selection sort, and merge sort. These sorting algorithms, they are very slow in performance. For example, if you have 1000 elements, the time required to sort those 1000 elements using these 4 algorithms is very high. Okay, this is not an effective algorithm. The performance is very slow, but it is a very good starting point. And by implementing these 4 sorting algorithms, we have learned how to use array indexes, and also we have learned a great deal about for loop and for each loop kind of thing. So I hope you have learned a lot from this lesson or this module on arrays. Also, I hope this last PowerPoint presentation is can help you with recap. I mean, doing a recap of whatever we have learned so far on arrays. Thank you. If this video has been helpful to you, then please subscribe. Also like this video and share it with others. Thank you. I will see you in the next lesson.